Hello students, my name is Sumit Mehta. Today in this lecture we will cover what are irrational numbers and the theorem based on irrational number. Irrational number is a part of a real numbers. So I will cover this irrational number as a part of real numbers chapter. Okay. So let me write a theorem first for you. It states that let P be a prime number if P divides A squared, then P divides A where A is a positive number. This is a theorem. From now onwards, after proving the theorem, I will use this directly as a property, okay, in my next questions. So what is the solution or the proof of this theorem? States that, so let me write, let the prime factorization of a number A, I can write prime factorization as P1, P2 up to Pn, where P1, P2 are all are prime factors, all are prime. Okay. Therefore, I can write directly A square will be P1, P2 up to Pn again into P1, P2 up to Pn. Okay, this I can write this as P1 square, P2 square means the square of all the prime factors. These factors can be same, but these are always prime, means it can be 2 into 2 into 2 n times 2 also. It can be 2 into 3 into 5, something like this. These factors can be distinct or same also, but these all should be prime. Okay. So according to the arithmetic theorem, fundamental arithmetic theorem which I discussed in my previous lecture, it states that these are the unique part of this. Okay, means A square. So I can say that, so what I can say from here is, so the unique factors of A square will be P1, P2 up to Pn. So hence A is equals to P1, P2 and P divides A, which I want to prove. Now I will give you some example what this theorem states. That means, let me give you one examples how what this theorem wants to say. Okay, let me write one example first. So this is the question. We have to prove whether root 2 is irrational or not. I'll assume to the contrary that root 2 is a rational number. Means I can define this in the form of a by b, and b cannot be equal to 0. Okay. If I take the square on both the sides, let me write this as root 2 times b, and if I take the square, which is a square is equals to 2b square. Now from here we can see that a square is divisible by 2, and from earlier theorem which I states that let P be a prime number. Okay, so it states that A should always be divisible by 2. So I can write A is equals to 2c, some other constant. Okay, if I replace this number as 2c, this is 4c square is equals to 2b square. Okay, so what I am getting here as 2c square, b square. Since I am getting this, b square is 2 is a factor of b square. So b 2 is also a factor of b, which cannot be true because a and b are two co-prime numbers. Means they cannot be same. Like co-prime numbers are these numbers which are prime to each other. So if B is having a multiple of 2 and A is also having a multiple of 2, then these two numbers cannot be co-primes. Co-primes means these numbers should not have a common factor except 1. Co-prime numbers, let me write the what are co-prime numbers. Numbers should not have a common factor except 1. So these type of questions might come in exam in which you have to prove whether root 2 is irrational or not. Okay, so guys, be ready for these type of questions and stay tuned for more lectures on this chapter. Okay, and download our app of Scholar Learning from Play Store. Thank you, students.